This is the 5-4 notes for Calculus 1. This entire section basically revolves around one concept called the average value of a function. So you're going to learn about what this means and how to apply it. It's a pretty short section, but the main concept you need to get out of it will be that, which I'll cover in 1 second. Okay, up top here, I'm going to read. It says, many times in the application of integrals, it might become quite useful to determine the average value of a function. For example, suppose that a hiker's trail's elevation over the course of 5 miles, which we'll represent as x being between 0 and 5, is represented by the following function. So this represents a hiking trail's elevation where measured above sea level in miles. In this scenario, it would be quite interesting to determine the average elevation of the trail along those 5 miles. Now, you might not be interested in this, but I could see somebody who likes to hike, or maybe even if they ride a bike or something like that, they might be very interested in elevation, because obviously elevation means riding up and down and all types of exercise stuff. So if we needed something like that, we could actually derive a formula that could give us the average elevation of that trail, or any function in general. So let's say we return to our Riemann sums for a second, which were always on the interval AB. Remember, we broke up each one of the partitions, the width of the base, and using the change of x formula. So everybody should be pretty familiar with that. And we found all the heights by taking f of x star k. So basically find the x value, which is where the specific grid points are, plug it into the function, that's your height. Well, it makes sense that if we want to find the average value of the function above sea level, or the average elevation, that we probably want to find the average height in doing so. So how do we find the average height of, let's say, n number of things? Well, what would we do? We would find the height of the first one, the height of the second one, and then plus the height of all of them. Let's say n was 5. So we'd find the 5 heights, add them together, and we would divide by 5 again. That's how we find a typical average. Well, this represents right here, essentially, the average height. Okay, so we can actually take that equation and manipulate it. Why? Look at this. So can't we solve this for n? So solve it for n, because if we could plug it right in there. So we're going to solve this by n, and when we do that, we end up with this as our value. So we're going to take that, and we're going to put it right there to get this equation. Okay, just like that. Now, b minus a is actually a constant. Before we do anything, though, we should probably, since we have a fraction and a fraction, we're going to, since we divide by a fraction, we multiply by its reciprocal, so we flip this and multiply. So the change of x ends up being multiplied by the top, and the b minus a stays on the bottom. But as I stated, b minus a is a constant, which means we can move that out like this, times this expression. But real quick, does everybody see that this is the Riemann sum calculation? And we learned that this is the equivalent to the integral from a to b of f of x dx, which means we can replace it with that, and look what we end up with when we're done. This, therefore, represents the average value of a function. In other words, in this problem that we're doing, the average height of the elevation. And that's why this formula is interesting when it comes to applications when dealing with definite integrals. Okay, our next step is to apply this to the actual hiking example. Realize this is so, if you understand the last section, this is so simple, because you already know how to do this. So the only thing you have to add on to that, or adds an improper word, how about multiply onto that is the constant 1 over b minus a. And don't you get a and b here? Like, it's super simple. It's just putting a constant on your definite integral, and that's it. So when we go through this, that's basically all we're going to do. Now, note, what I didn't mention so far is we refer, a variable we use for the average value of the function is f bar. F bar. So for you familiar with statistics, for those of you familiar with statistics, x bar is the sample mean or the average. So bar is often the variable or the written piece that you put on a function, like the extra part. I don't even know how to say it, but the extra part you put on a function when you want to signify that it's the average. It's the bar. So how do we find this? So let's go to our hiking example. So our f bar for this example would be 1 over b minus a. Okay, well, what is a and b in this problem? Let's return. So right there. So real quick, we're going from 0 to 5, which is a and b. So we're doing 1 over 5 minus 0 times the integral 0 to 5. So look at it, they repeat. So easy to come up with. I love it. This is so simple to do. Then of our function. So our biking trail function is not very nice, but would we expect that to be in such a biking trails are not very consistent. They're all over the place, so we would not expect a very hiking trail. We would not expect a very consistent function. So this is the polynomial that represents it. So let's look at the graph real quick. So the graph here, so this is our function, right? This third degree polynomial that we have. And we're trying to find the average elevation. So the average elevation is going to be some value between these two, somewhere in the middle. Now, right now on the graph, it is actually marked. So we're going to verify that that is where the average elevation is going to be of that trail by doing the mathematics over here. So what do we get? We get 1/5 as our constant. Then we have to integrate this polynomial. So we're going to get 60 x to the 4th over 4. We're going to get minus 650 x cubed over 3. We're going to get 1200 x squared over 2. And 4500 x, which we have to evaluate from 0 to 5. Okay, a little bit of simplifying. So 4 goes into 60 15 times. So this is 15x to the 4th. The second one's not going to change. This is going to be 600x squared when we simplify. And that's all the simplifying we can do. So luckily, we do have a 0 here, which means we don't have to do a whole lot of work. But we do have to do the 1/5 on the outside, and then we have to substitute in 15 5 to the 4th minus 650 thirds 5 to the 3rd plus 600 5 squared plus 4500 times 5. And that is all going to be minus a big fat 0, right? So if we do this, I'm not going to do it out, but if we do this entire calculation, we're going to get approximately 3,958.33 feet. Now you'll note, yes, I usually give answers in exact, but we're doing an application problem here. So let's use an approximate value for that. So our answer here is that. If you look at the graph, this is actually a pretty good estimate right here. It's right below 4,000, just there. So that's going to be the average elevation of the whole trail, which you would expect to be somewhere between them, obviously. You have the high end here and the low end here, but somewhere in the middle will be the average. So that's how you use this formula. It's pretty straightforward stuff. You just have to, there are a variation of this, which we'll get to in a second, but other than that, this is what I'm looking for you to do. Alrighty, number 1. Do one example of this, and then we'll talk about the next type of problem that's related to this. Let's say we have the function 2 plus 3 root x on the interval 9 to 16. Our goal is to find the average value of the function, f bar. So let's just jump right into it. So what is a and b in this problem? 9 and 16. So we're going to do 1 over 16 minus 9 times the integral from 9 to 16 of 2 minus 3 root x dx. So always remember your dx's. Small note here, remember we have a radical, which means that we have to change that to x to the 1/2 in order to do anything for our problem. Next step, this is 1/7. Now we keep it on the outside with a bracket. We have to integrate 2 minus 3x to the 1/2. We're going to get, remember, 2, we plop on an x, minus 3. Remember, 3x to the 1/2, when we integrate that, we get 3x to the 1/2 plus 1. So 1/2 plus 1 is equal to 3/2. So we're going to get x to the 3/2 over 3/2. All from, actually, let me do parentheses for this. All from 9 to 16. Alrighty, a little simplifying. Let's do that over here. So this right here is the same as 3 times, take the reciprocal of 3/2, 2/3 in the front, x to the 3/2, which will end up having these 3's cancel out. So you'll actually just get 2x to the 3/2. So let's rewrite that over here. We got 1/7. We're going to have 2x minus, it's going to be 2x to the 3/2. But we don't want to write 3/2, we want to write the actual radical. So we want to write the square root of x cubed. Okay, so that should be just basic algebra stuff that you should know, but I know students still struggle with this. Remember, the 2 is the root and the 3 is the power. Okay? So this is our setup. For the next step, we could take out a 2, by the way, here. And I kind of, I don't know, part of me wants to because it's the same number for both of them. But why don't we just leave it the way it is so we don't get a lot of confused students. So 1/7, this time I'm going to throw my bracket in. Why? Because I have to do 2 times 16 for the first part, 2 times the square root of 16 cubed for the second part, then minus, in parentheses again, 2 times 9 minus 2 times the square root of 9. Why did I do that? The square root of 9 cubed, all in the bracket. Okay, so what do we got here? Let's do a little bit of mini math here. This is 32. The square root of 16 is 4. Cubed is going to be 64 times 2 is 128. 2 times 9 is 18. And then the square root of 9 is 3. Cubed is 27 times 2 is 54. If you put all of this together into one common value, you're going to end up with, so this whole thing here, by the way, is 88. So if you put it all together with this 1/7, you're going to get 88/7 as the average value of the function. So this is not an application problem, so I'm just leaving it as an improper fraction, as an exact value. The remaining part of the section will concentrate on what's called the mean value theorem for integrals. I don't actually call it that. As a matter of fact, I try to rule against using this term just because I want you to associate the MVT, the mean value theorem, with the previous section with Rolle's theorem and all of that. I just basically refer to this as an extension of average value of a function. So you'll see in here that it's the reason why it's called the mean value theorem is it's a similar concept in this fact that this is the key. So you're trying to find out where your function itself is actually equal to its average value. Okay, that's the best way to say it. So let me give you an example real quick. So where are we? I skipped it. Where'd I go? Oh, it disappeared, right? Okay, so here, let me get rid of all this stuff. So let's suppose in the hiking trail example that I wanted to know when I actually hit the average elevation. So I have learned that the average elevation is 3,958, blah, blah, blah. I would like to know at what point during my journey I will actually cross the average elevation. So in other words, what's the value of x in which this occurs? That is the following concept that we're going to do. We're trying to determine when the function itself is equal to its average value. So this is actually quite simple as long as you follow with the concept itself. Very simple. Why? Because what do you have to do the problem? You have to find f bar again. Either way. The big thing is once you find f bar, which is indeed just a number, all you're going to do is set it equal to your original function and solve. That is what this is about, and admittedly, it's very simple, if you understand this, of course. Okay, so let's do that. So suppose we need to find our average value. Now note, this is the question it asks before we get there. It says, find the points at which the function 6 minus 4x equals its average value on 0, 4. It's literally telling you what to do. It's telling you to take 6 minus 4x and set it equal to its average value. So the question is good. I like it. It'll tell you what to do. So again, we need to find f bar in order to set it equal to the function. So let's do that. 1 over our a and b are 4 and 0. Integral from 0 to 4 of 6 minus 4x. So we've started with a linear function, which you see right here. Let's find its average value. So we're going to get 1/4. We're going to integrate and get 6x minus 4 times x squared over 2. And we're evaluating from 0 to 4. Obviously, this is going to become 2x squared. Okay, so let's do our evaluation. So 1/4. We're going to do 6 times 4 minus 2 times 4 squared. All right, but then 0 cancels out everything in here. Okay. Just a side note on that, by the way. The reason why we can do that every single time is because it's a polynomial. And the polynomial that you find in here is always going to have all x's. Just be really careful, because if this was a trig or e problem and you tried just saying, oh, it's all 0, it's not going to work. Because the cosine of, let's say, 0 is not 0. E to the 0 is not 0. So these types of things you have to be careful with. I'm not plugging it in because it should be obvious by now that the polynomial is going to happen that way, but realize if it wasn't a polynomial, this would not happen. So always check before you go and leap and do it. So worth noting that this is 24 and this is 32. So if we do the math for this, we're going to get 1/4 of -8, which is going to give us -2. Okay, so I'm going to put a cloud here. This is not the answer. It's just this is the average value of the function. So if you go to the graph, you'll see that the average value of the function has been marked by a dashed line at y is -2. Okay, it makes sense that it's y because f bar is an f. So f of x is always y. So what are we trying to find? We're trying to find where our original function meets its average value at what value of x. Now, according to this, it appears that it's going to be at x is equal to 2. How do we find that for sure? Because we can't assume that. So this is step 1. Step 2 is we take our original function and set it equal to its average value, which is -2. Solve, so -4x is equal to -8, x is 2, and this is the answer to our problem, which is indeed the number 2. So there is absolutely no chance that you're going to get a graph for this. So realize, other than graphing it yourself, right? So online you might be able to, but in a class situation you wouldn't. So you have to be able to do this basically blind from the graph. So x equals 2 would be the end. It does say points, but I'm perfectly fine with you writing just x equals 2. If they really, like in my math lab, want that coordinate, then you just give it to them. Because you would write, well, 2 would be the value of x, and -2 would be where it actually meets. So this just in case. I always give you that because I don't want you to get confused if my math lab throws you for a complete wrench. Sometimes it does. It can be annoying like that, but for the most part, it's a good service. While this is a pretty straightforward concept, there are some scenarios you might run into where you might be sort of taken aback. So I made sure in number 3 and 4 to include such scenarios. Something different than what you've seen before is what I'm getting at. So again, we're asked to find the points in which the function f of x equals x minus 3 squared equals its average value on 2 to 5. So clearly we're looking at a to b here. All right, so we're looking, the first step is always we find f bar. So we're doing 1 over 5 minus 2 from 2 to 5 of x minus 3 squared. But I'm not going to write x minus 3 squared because x minus 3 squared is not going to do anything for us. We want to FOIL this. Remember, this is not x squared minus 9 or plus 9. This is x squared minus 6x plus 9. If you're looking at that in a funny way, I'm kind of having convulsions, but that doesn't matter. Remember that you're multiplying x minus 3 and you have to FOIL times x minus 3 to get that. All right, so I'm going to write x squared minus 6x plus 9 dx. So what do? Same thing we've always been doing. We get our 1/3. We want to integrate, so we're going to get x cubed over 3. We're going to get, ooh, that is sloppy, x cubed over 3. Minus 6x squared over 2 plus 9x evaluated from 2 to 5. Simplified, clearly this is going to be 3x squared. So let's evaluate. 1/3, we're going to stay on the outside. In parentheses, we're doing 5 cubed over 3 minus 3 times 5 squared plus 9 times 5 to start. Then we have to subtract 2 in there, 2 cubed over 3 minus 3 times 2 squared plus 9 times 2. Okay. A lot of little math stuff we have to do, so just for argument's sake, this is 1/25, this is minus 75, this is plus 45, this is all going in your calculator. 8/3 minus 12 plus 18, it looks like. Yep. And we're going to get, in the end, when we do all of this math, we're going to get 1/3 of, believe it or not, just 3. I know that sounds crazy, but believe it or not, we actually get 3. Okay, so the average value of the function is now located at y equals 1. So what is this question asking? It's asking for the points in which the graph, which is our parabola, meets the average elevation or average function. So that looks like it's going to occur at 2 different points. Now, you wouldn't have the graph, so you wouldn't know that, but it does appear that that's the case in this problem, hence why we're doing it. So again, how do we find those values? We're trying to find where the function equals its average value. So what do? We take our function x minus 3 squared and we set it equal to 1. Okay, we could have set this equal to that as well, and that's perfectly fine. So I just want to, actually, I'm going to do it on the side real quick. So if you set x squared minus 6x plus 9 equal to 1, you would get x squared plus 6x plus 8 equals 0. And you would end up with x minus 2, x minus 4, right? So most students would prefer that because it makes more sense to them. But I'm going to do it in a more algebraic way. In terms of something that you might not have seen for a long time, so worth showing you. So let's say that we decided to solve this, but we don't multiply it out. What could we do right now if we needed to isolate x? Well, we could take the square root of both sides immediately. The square root of x minus 3 squared is just x minus 3, and the square root of 1 is positive and negative 1. Okay? So if this is the case and we add 3 to both sides, we get 3 plus or minus 1 on the right side, which ends up being 2 different answers. 3 plus 1 is 4, 3 minus 1 is 2. Now, again, you probably haven't seen that in a while. Maybe some of you might not even remember doing that. But that is a legal maneuver and something worth showing all calculus students. So I wanted to make sure that you saw something like that before I moved on anywhere. So basically, these would be the answers. And if you're looking for the coordinates, it would be 4, 1, and 2, 1, as you see on the graph here. Note that whatever your value of your f bar is always going to be the second number, and whatever x's you get are going to be the first number in your coordinates. Okay, for our last problem, we're going to pick up the skill level a little bit, and again, a type of problem you could run into and maybe be stuck on for a little bit. So I'm trying to avoid that by just showing a good example of it. Same exact directions, except we have a new function and a new interval, so we should be able to jump right into this, finding our average value of our function. Average value. So 1 over, our a and b are 1 and 0, so that's pretty nice. 0 to 1. This we want to change to 2x minus 2x squared. dx. So in a very nice manner, this entire thing ends up being 1, which means we don't even have to include it in our work. We can also take a 2 out, but yeah, I'm just going to leave it as is. I tend to, again, when the constant's already out there, I tend to just leave it as is and not take stuff out, but you can take a 2 out if you like to make life easier. But let's integrate first. So 2x squared over 2 minus 2 times x cubed over 3. We have to evaluate that from 0 to 1. Now note again, there is no number here because it's just 1. So simplifying, this clearly is going to get us x squared, and this is going to be 2/3 x cubed. Okay, let's evaluate. So we're going to get bracket, we're going to get 1 squared minus 2/3 of 1 cubed minus 0 into both of them. Because it's a polynomial again, we end up with a big fat 0 for our work. So we're going to get basically 1 minus 2/3, which in the end is just 1/3. So this is going to be our f bar, and if you look on the graph, that's exactly what we ended up with. So we're looking for when our average function, our typical function here, meets our average value. So again, what do? We set 2x, 1 minus x, equal to 1/3. Now, note, in this example, there's not really a lot to do. So we definitely need to distribute this and just do the original problems example and get this. I really do not like what I'm looking at here. Remember that I do have an x term, an x squared term, and a constant, which means this is a trinomial. It's just not written the way it needs to be. So the goal is we need to get 0 on one side of the equation, and ideally we want, so let's do that first. So here, let's subtract 1/3 over, get 0, and ideally we want the fraction to be gone, and so there's no negative in front of the x squared term. So let's rearrange. So negative 2x squared plus 2x minus 1/3. We want to get rid of this negative and this 3 in the same step. So we want to multiply both sides by -3. Okay, by doing so, we're going to get 6x squared minus 6x plus 1 is equal to 0. All right, so ideally we would want a factor. So here's an issue though. So this plus sign sitting here implies that I am going to take basically multiples of 1 and combinations with 6 and get them to be a -6. So just as an example, let me just do an aside over here. So I could do 2x1, 3x1, for example, right? But the signs both have to be negative for this signage to work out. If I do that, it looks like I'm going to get minus 5x. Okay, well, what's the only other way I can change this that's going to create a different answer? I can change it to this. But it looks like this one I'm going to get at minus 7x. There's no other way to really manipulate this, which means that this is not factorable. So here we go again. If it's not factorable, then what do we need to use in order to find the value of x? We need the quadratic formula. So remember, negative b plus or minus square root of b squared minus 4ac over 2a. So let's go ahead and do that. So b, it's going to be negative, and then b is negative 6 plus or minus negative 6 squared minus 4 times 6 times 1, all positive numbers, except for the original negative 4, over 2 times 6. Okay, we're going to end up with positive 6 plus or minus the square root of, it looks like 36 minus 24, which is 12 over 12. So 12 actually is the same as 2 root 3. So we can simplify that further and get 3 plus or minus root 3 over 6. So we're going to take a 2 out of here, and out of here. And we end up with this. So this is basically the answer. But it'd be nice to be able to verify that with some approximate values. So this is going to create two approximate values of 0.211 and 0.789. So let's go up to our graph. It does appear that we're approximately at 0.211 for our first point, and it does appear that we're approximately at 0.789 for our second point. So that would be basically the result of the problem. I wanted to give you one with the quadratic formula just to verify that all was good in case you ran into that.